Okay, so Graham's coming in with it. So we would do, I think you meant gamma for the first part. So gamma entails fundef of x, tau, and e. And then we'll go ahead and put the colon there. And we need to eventually replace that question mark with something. And so remember, Graham just grabbed that from our AST. We're going to use the abstract syntax when defining these rules. And no worries, Graham, about not knowing all the capital Greek letters. And usually it's not till graduate school you figure all those out. And there's still some, like, if you wrote them, I wouldn't know what they were. You tend to use the same 4 or 5. So we have this rule. What do we need on top? So it's a function definition. What type does a function definition have? We can actually fill a little bit of this question mark out now. We know it has a certain form every time, at least part of it. And if you need a reminder, remember we've defined type to be either you have a num, you have a bool, or you have a function type. I think we put type after each. And then remember, fun type takes 2 types. So can I do anything to kind of start filling out this question mark here? Just kind of based off of the types we have available to us. Yeah, so I can definitely put fun type here. Okay, we'll usually draw that as an arrow, right? But now I don't know what goes on either end of the arrow, and we won't know that quite yet. So good kudos to Arthur and Graham for being on top of that. Now, how can we figure out what goes in those question marks? Anyone have any ideas? Actually, one of the question marks we can probably fill out now without even messing with any of the premises. Yeah, so Graham says functions can be on any type, so maybe just A or B. I like it. And actually, I want to change tau. I'm actually going to write this differently. I'm going to use an A here. Now, what can I maybe replace, say, this question mark with? Conlon says B. How about the first question mark? Conlon, I think you're getting ahead. We're going to eventually want to call this one B. We have to do some premises to figure out what B is. Yeah, so maybe do A to B. I'm a little unsure about B. We have to say some stuff about B, but why can I can feel pretty safe about this A here? Why can I feel pretty good about that?
We sort of already gave like the parameter X a type A.
Right on. So this parameter X has type A. We know this already. We've given that, yeah, and Joseph says the same thing. It's your first parameter. We've already given it a type. So we can be really sure that the function's going to take an A, right? Because it's part of the actual syntax here. We've included that so we can do type inference. Now, how do I get B? Because right now B is kind of unconstrained. It could just be any old B. I need to say something about, you know, some of the stuff we have here in order for that B to be kind of true, right? So what goes up here? What goes above the line? We need to check the type of something else with our fun def. Yeah, so Joseph says give the context of B maybe. Yeah, so we need to like figure out what context, what expression maybe gives us a B, right? So I kind of like that. You're kind of working backwards here. This is a little different. So something's going to be of type B, that's for sure. What ought to be of type B? Graham says make sure X is a string. X is definitely going to be a string. It's constrained um, by our grammar up here already. So we don't have to worry about X being a string. But what do we need to check? We type check on expressions, I think, right? So what expression do we have in this rule that we can type check? Yeah, so Graham says make sure E has type B or output some B. So we're going to type check E, and we need a context to do that in. What context should we be type checking E in? Is it just gamma, or do we have something else as well? Definitely going to include gamma, so I'll put that up there, but we need a little bit more than just gamma itself. Yeah, so Joseph says X added to gamma. I like that. So we're going to add X to gamma, and X has type A. We write that like that. So we add X of type A to gamma, and then we say the expression E, the body expression of the function, needs to have type B with respect to X being of type A. Okay, so what does that look like concretely? Say I write something like function X of type num and do something like X plus X. Okay, so I can check the rule for, we kind of assert X is of type num, right? So that's where we add it there. And we have no other context here. So we started with the empty context. And now we need to check that E is of type B if we have X in scope. So X plus X, well, that's plus, and plus expects this to be a number and this to be a number. Well, X with the variable rule, we go and look into the context, this gamma here. Okay, well, an X has type num. We can just kind of look off to the left, right? So this rule does comport with how we would want to try and type check this. Okay, so right on. Good work, guys. Is this rule finished? Are we done? Is there anything left to type check? You know, E's been type checked. We kind of assert X as type A. Is there anything left to do? I don't think so. I think we're done with this rule. So this rule is finished. Put a nice box around it. I haven't put a box around anything yet, but I'm going to put boxes around stuff today. We have a question. What's the operator comma here? So this comma right there just means we're extending gamma. So I'll put that as a note down here. This means we are extending gamma with the entry X has type A. That clear that up? I think we used that notation last week. I didn't dwell on it much, but it's just a regular old extension. We used a different notation for sigma in our evaluation environment, but this is gamma in the typing context. So it's a little different. The notation changes a little bit. Any questions about this first rule we've gone over today? Awesome. If silence is good, I guess. If there are, go ahead and type those in or ask them. I think there was something else I wanted to remark on there. It'll come to me. It usually does. Okay, so let's keep moving on. And let's talk about function calls. Natural extension here. So function calls. And just as a reminder per usual, it has the grammar form fun call, and it takes two expressions with it. Or func call, or I think it was fun call that we called it this semester. And then it has the AST form, that abstract syntax tree. It'll be fun call. And we'll usually call it like F and X. Could be F and E. It need not be two variables, right? It could actually be a fun def. And like an actual expression. That part doesn't matter, just a reminder there. And then the concrete syntax will look something like this. F of X, something like that. Hopefully that's not surprising to anyone. Now let's do this one with an example. So let's take an actual example of a function call and let's try and type check it ourselves. So let's say let F, we'll use that function from above, equal function X of type num, X plus X in F of 10. I want to type check this whole program. Okay, so really this last part, how do I go about doing this? Okay, we're going to try and derive a rule out of this, but can anyone walk me through, someone comfortable, hopefully unmuting their mic, can you walk me through how you might type check this whole program by hand? And if we fumble while we're trying it out, that's perfectly okay. No one wants to take it, I can. That'll be sad.
I usually try to work backwards, so I would start with my F.
Okay.
I would figure out what that represents. And I would see if my argument of 10 or my parameter of 10 matches up with whatever it's asking for.
Right here. So what's the type of F? Let's start with that then. So F's going to have...
Seems to be a fun type.
Yeah, so it's going to be a function type. And then a function type on what? What's the input and output type of that function?
Num to num.
Num to num, right on. And then you said the next thing you do is you go and check this part, right? And make sure it kind of comports to F. Type of 10 is just num, right? And then we need to make sure that the input type here and this type are the same, right? So make sure, I'll label these. We'll call this one A. We'll call this one B. Then make sure A equals B, right? Does that capture what you're going for there?
Yeah, definitely.
Perfect. Oh yeah, and to answer Viete's question, the question was, did we define function somewhere, or is it just a keyword for a generic function that can be defined somewhere. So remember that function here, I think that's the one you're referring to, was the concrete syntax for function definitions. So if you go back to when we started talking about functions a couple weeks ago, I think at this point now, that was the syntax we decided. It might have been last week. No, I think it would have been 2 weeks ago. Yeah, so it should look, that's just the concrete syntax to denote a new function definition. So, okay, well, let's try and sum up this process as a single inference rule. And you only need one inference rule. It's nice and concise that way. I'll give you guys the boilerplate this time. So we have gamma and tails. Fun call of, I'm going to put E1 and E2 here to be really careful. Has type something. We don't know what type it has yet. We'll get to that part in a second. So remember, the first thing we did was, okay, well, let's go and figure out what type F has. That was the first part of our process. Okay, well, F here is going to be that E1. How can we figure out what type E1 has? Well, we can just put a premise in that E1 has type under, and we should say E1 under gamma has type, and it better be a function type. Otherwise, we're going to get into trouble. And we'll call this an A to B function. Okay, so E1 has a type. It's got to be a function at the end of the day. And that could be, E1 could be a variable. E1 could be an actual function definition. We don't know. We don't care. We'll let the other rules handle that part. Okay. Now, what's the second part I need? So we said earlier that first we check the F part, right? And we say, okay, well, let's go figure out what F is. Then we said, okay, well, let's go figure out what the arguments type is. It was pretty easy here. It was just 10. But what do I need to write to check the type of E2 here? And if you want to type that in or unmute and say it, either one's fine with me. What should we write to check the type of E2? Graham says E2 should be A. Okay, so E2 has type A. Under what context? Yeah, so Arthur's typed out the whole rule. Kudos for that. Yeah, and it should just be gamma. We don't need to extend gamma with anything because that extension part happens inside the function definition as opposed to function calls. Yeah, and Arthur, no worries about capital gamma. It's a hard one to find the right ASCII for whatever, however you're typing it in. Yeah, so that's our rule. What's fun call's final type? What should go in this question mark right there? Oh, I guess actually Arthur's already put it there. So it should be B, right? So it's whatever the function outputs, which makes sense, right? So here, F and 10, we have to make sure these two numbers match up, but then otherwise we get this as our output type. Okay. Now, why, what would happen, say, if I made E2 C? Why does that not capture type checking here? Yeah, so Graham says we're using E2 as an argument, so it would be a type error, right? So as a reminder, remember that the whole point of type checking was to make sure we don't do operations on anything of the incorrect type, right? So we're not trying to add, say, Booleans or strings together, because that doesn't make any sense if you're using, say, arithmetic addition. This is the same sort of thing, but captured really in a single rule. And then I think Arthur has one too. It would be potentially poorly typed. If A and C are ever different, then E1 might not be able to perform the operation, right? This rule isn't entirely incorrect. I think Arthur pointed this out well. C could be A, right? We certainly could, there's nothing here that says C and A are different, so they could be the same. But we actually want to really assert that those are the same thing. And that really captures the essence of what type checking is this rule. This is kind of the most important rule in our type checker. If you really kind of dig into what type checking is this is the one that's going to make sure we don't perform any bad operations. Now we've done that explicitly for things like addition and subtraction so far, but this captures it for the functions we're writing. So to answer your question, Kate, yes, it is. Hang on until later this evening for the actual due date extension date, probably Thursday or Friday. So stay tuned. Kate was just asking about the extension for homework form. So sweet. So that rule captures function calls. Like I said, probably the most important rule we write for type checking. It's really cool, really simple too. It kind of highlights how, all these other rules are handled by other stuff. So that's kind of neat. And I think you guys probably saw maybe how this works and how the other rules apply yesterday in recitation with those kind of proof trees, right? So hopefully the reason we write inference rules in this style make a little bit more sense now. Any questions about this rule? Great engagement online. Great work, everybody, so far. Okay, so let's get on to our last rule, which is recursive functions. Now, this is the really nasty one. And then a reminder of our syntax again. So we have grammars. The grammar for recursive functions was let rec, and then let rec took first the name of the function, and then the type of the function. It then took the argument to the function and its type, and then it took an expression. Oh, this isn't the grammar. This would be the AST, I guess. I went out of order this time. Then the expression for the body of the function and the expression for the rest of the program. So let me bump this down and fix that up. So the grammar would then be let rec of string type string type expr and expr. And then the concrete syntax is going to be let something like f of type, we'll just use a to b, equal function x of type a, eb in EP. Oh, thank you for answering that question, Arthur. Appreciate that. If we want to go back to that, I'm happy to read that off too. So the question, actually, I'll just do it just for the recording's sake. So the question was, could I read the last rule kind of in English prose? So in context gamma, function calls with the sub-expressions E1 and E2 have type B so long as in gamma E1 has the function type A to B, and then E2 has type A. Okay. Okay, so let's keep back to recursive functions. This is going to be fairly similar. How might we type check this? Is this going to be radically different than doing, say, let and function def kind of combined? Is it going to be really any different, do we think?
My guess is probably gonna be pretty similar, but like similar to the last two we did, but we definitely have to do something special with the context or environment we're in.
You think so?
Yeah, I think so.
That was going to be my follow-up. Do we need to do some special trick again? Okay, well, let's run with it and try and answer that question. I'm going to write that question down. Will we need another special trick? To deal with recursion. Like in the operational semantics. Okay, let's try writing this rule. So it's definitely going to be similar to let plus function def, right? So if you guys have your function definition, your let rules handy while we write this, that'll probably help. And I'll get us started again. So we have in the context gamma, we have let rec. And now we have to write all this out in the right order. F, tau of f. We have x, tau of x. We have EB, and we have EP. Has type something. We don't know what that type is yet. Okay, so we have a lot of stuff going on, or a lot of parts here to deal with. Where should we start? Where could we start? And if it helps, you can look up here at the concrete syntax. That might help. How would you say maybe type check that by hand? I'll give you guys a second to think about it because there's a lot of moving parts here. So first we need to check that F has type A to B. So that F is a function type, right? So first off, I think we can actually express that pretty easily by changing this T of F to a function type. So let's remove that. And change the second argument to be A arrow B. Does that capture what you're going for? Then what else can we do? We can actually do something below the line right now to constrain the rule a little bit as well. Someone has an idea what that might be. And I draw your attention to T of X. Yeah, so T of X also has to be A, right? Because the A here corresponds to the T of X here in the definition. So if you look here, we want this A and this A to be the same thing, right? Otherwise, the function type won't be proper, it won't be right. So let's start by doing that as well. So we make T of X instead just A. Can we really do anything below the line now to constrain the problem, or do we have to start getting to our premises now? Any ideas? Can we do anything else on bottom?
Does on the bottom here where you have A to B and A, those two additions that you have made or augmentations, did those effectively do the checking for you?
In some respect they do, especially because they're part of the form, right? So up here we've augmented, say, our let bindings to have types with them. So yeah, you could look at it that way, as it's kind of doing the check. It basically would mean, if you recall from recitation yesterday, it would mean we couldn't construct a proof tree of any other form, right? So for instance, I couldn't have num type there on its own. It's constraining the problem in that way. Basically, in that we wouldn't have a rule for num type, and therefore you can't construct the proof tree. Yeah, so effectively that does a little bit of the type checking, at least in part. It makes sure that they're the same as each other. So it's part of the step. It's not really doing any checking per se, but it's making sure everything kind of lines up with each other, if that makes more sense. And that's really more of a syntactic check too. It's not really doing, yeah, so I wouldn't necessarily call it, that's not really doing the type checking part per se, if that makes sense.
So I guess what's creating confusion for me is the range of possible premises, or the exclusion of premises, and how that could affect this. So say we check that, you know, E sub B and E sub P, they have the right type or whatever. But F is, you know, C to D or whatever. But we only have those other two, the E sub B, E sub P checks. Well, then we could produce a recursive function F, which is A to B, but actually is D to C to D because we never checked it or something.
Yeah, so we have to do a little bit more with the premises too, right?
Yeah, I guess that's kind of what I'm getting at.
Yeah. So we do definitely need premises to do actually what you just said. So can you help me come up with one of those? What was one of the things you just said we needed to check?
Well, I think we would need to check E sub B and E sub P.
Right. So we need to check these two, right?
Right. I don't really know what role they play per se in the recursive definition. So
yeah, so they're going to actually behave just like they behaved with function definitions and let bindings, really. So remember, EB, that's going to pretty much behave the same as a function definition expression. So if we recall from earlier, if I scroll up, we had, you know, E corresponds to that E sub B, that E of the body of the function, right? And we type checked that okay. And then if you look up your rule from last week for let bindings, E of P is just the rest of that program. So we just need to type check these, right? And we actually do have a type we would expect them to be. So let's start writing that down. So like E of B has to type check to something. And it's going to have some context. We don't know quite yet what it is. And E sub P should also be type checked. Let's start with E of B. Okay, so that's the body of the function. So if you need a form, it's the part up here, highlighted in pink. So that pink part, how do we type check that? What's the context that we want to type check that in? Any ideas? What was the context we checked E sub B in earlier with the function definition rule?
Wasn't it like the context of gamma, like including X of type A?
Yeah, right on. So we had the context gamma augmented with X of type A, right? And that comports with what we know, right? X has type A down here. Do we need anything else there? Or is that it? Do we need anything else with the context here? Think about the recursive part of the recursive function. Say I'm defining f maybe up here. And I want inside f, this pink part refers to f somewhere. Do I have f in scope right now, given this context? What do we think? So here, in order to support a recursive call, we need to do one more thing. We need to also add f to the context here. And that's going to be what lets us type check the recursive part. So this is that special trick part that Conlon was referring to earlier. We do have to do something here. Does this make sense to everybody? Anyone confused? I'm getting a lot of silence right now. I don't like that. Nothing, no questions. Everyone's good with that. All righty. I'll take that as a good sign. What should go over here in the question mark? What should the type of EB be if this is well typed? Yeah, Ben says B. I like that. So it ought to be of type B. That's so it agrees with its own type, right? If it's going to output something of type B, the whole thing better be of type B, right? That kind of makes sense, I would say. Hopefully that checks out with everybody. Now, What should we expect E of P to be? What ought that be?
That one evaluate to A.
It would evaluate to
Has
A.
with A.
Okay. Why should that evaluate to A?
How I think of it is like that in part would be like in X plus X makes another something of type X. So you can work with that in the function.
So, oh, remember E sub P is we're now moving on to this part, right?
Okay.
Are we talking about the same part right now?
I mean, yeah, I was, but
Okay. Gotcha. So,
wrong.
not quite A, because remember, A is just the input to the function. E of P could be anything. So for instance, if we went back up to that example from before, I might not even call F. Like F might not, it could just be 10, right? That's completely valid. So I don't actually have to call F. And I think there you're assuming you do call F maybe. Should E of P be A or B? Or should it be something else? What do we think? Take a look at your rule for your let bindings from last week. Arthur says A to B. I don't quite like that because E of P is not a function, right? E of P is going to be the output for the whole program. Remember, for a let binding is going to have some other type. It might refer to F. It might be B, but it doesn't necessarily need to be B. It's just got to be C. It's the context that's the interesting part here. And that's because in this context, we're going to have F added to it. And then the final type at the end is just going to be C. Okay, so remember that the type will agree with this E sub P. The whole program will have that type. Does that make sense to everyone? Or did I kind of lose you there? There's some confusion with the last part of this rule. Okay, Conlon says it makes sense. If it doesn't make sense, somebody say something pretty quick. Graham, I saw your post. I was trying to edit a question because I typed something in wrong. I just thought of that as I was writing the rules. So hang on a minute and it'll be back online. If anyone else had the quiz open, I pulled it off for a second. So. Okay, well, that wraps up our rules. I do want to do some kind of higher level talks now. So what we've done, right? So far we've talked about a lot more than this, but with respect to programming languages, we've talked about a few things. We've talked about the syntax, both concrete and abstract. Okay, if we want to add something to our language, we're going to typically start there. Start creating new syntax for it. And then there's also semantics, right? And a few different kinds of semantics. We have our operational semantics. That's our interpreter, right? And then we also have type checking. That's another kind of semantics. And so if we wanted to add something to our language, which we'll do, not really with tomorrow's stuff, but next week we'll talk about some language extensions for the functional part of our language. We're going to have to add stuff to every one of these little buckets here. So basically everywhere I'm about to circle, we have to add pieces to. So if I want to add a new construct, say maybe product types, we have to add new type checking rules for product types. We have to add new interpretation rules for product types. We have to add more concrete and abstract syntax for those types. This will pretty much be true for any construct we want to add to our language. It will be true for what we'll talk about tomorrow with the imperative syntax and adding commands to our language, but we probably won't do type checking because type checking is a little bit more difficult with those. But we will add operational semantics and new syntax as well. And every time we have like a semantics and a syntax, we'll typically add, if we're adding a new feature, we're going to update each pieces of this little chart here. Yeah, and good point. Arthur's saying he's hung up a little bit on the abstract syntax, and maybe what is it specific to lettuce or more generally what abstract syntax is? Because we can definitely actually touch on that again soon. Maybe tomorrow actually would be a good opportunity to do that and revisit that, because we talked about it a bit and it's a term that comes up, but maybe drawing the distinction wasn't always so clear. So yeah, so for sure. Oh, you're confused about the abstract syntax for the last rule? Waiting for typing. Oh no, that's okay. Yeah, the last rule threw you for a loop. That's okay. Well, let's go back to it. I didn't give you enough time to really type in a objection, and that was what I was basically covering. So just remember that this is kind of everything we've kind of covered in the language space. And if we want to update our language, add new features, we have to update each of these pieces as we go. So something to keep in mind. We'll kind of revisit this little graph tomorrow, probably, as we start talking about new features for the language. And we'll do that for probably the rest of the week, just talk about new features we can add. So yeah, let's go back to this rule in the abstract syntax here, though. So what was your question? Do you have a more pointed question that can give you somewhere to start off, Arthur? What does E sub B represent? So E sub B represents the body of the function. Whereas E sub P is the rest of the program. So EB is not that part. E sub B would be the defining part. So if I go back up to, where'd it go? Here it is. So E sub B here would be that X plus X. Is that better? So function, let's do E sub B. Let's see, function X variables. Not, wait, sort of, yes. Where you can kind of sub in the definition under X sub A. Yeah, so I'm not in love with the notation you just used, but yeah, you can think of this X plus X as being basically the part that you're giving 10 to. right? So I'm plugging 10 in here for X. Oh, no, that's okay. You don't need to polish your notation in chat. I understood what you meant, I think. So as long as it clears everything up, we're all good. Yeah, because actually the substitution you did means something different with the notation I usually use, which is why it was confusing. So definitely not your fault. It's kind of intuitive. I like what you did there. Just don't love it, if that makes sense. So, otherwise, I think we can wrap up there. Any questions about anything we covered today? Otherwise, I'll hang out for a few minutes. There's a lot of us in here, so I can probably answer some general questions that maybe the group has, or some common ones I noticed in office hours today, if you guys have them about the homework. Otherwise, have a good evening. Yeah, I'll hang out for about another 10 minutes. The quiz isn't quite up. I need to update one question real quick, and then it'll be online. So just a couple minutes for me to update that question. Otherwise, have a good evening, everybody. Keep an eye out for an announcement about the homework extension, and we'll see you tomorrow.